Welcome to day 3 of this section of pharmaceutical calculations. The topics in this slide packet will be on calculations related to IV infusions and parenteral nutrition. This, of course, is the same conversions table that you've seen in the other slide decks. It's provided for your reference and to assist in memorization for the assessment. Here's a table of the infusion solutions that were introduced earlier, which you'll need to know for the assessment. The only exception is lactated Ringer's solution, which you don't need to know. Otherwise, you need to know the ingredients or their concentrations for their assessment. Okay, IV bags generally come in 50, 100, 250, 500, or 1,000 milliliter volumes. Sometimes additional volume is added to an IV bag. So be sure to read problems carefully to see if the total volume of solution should include the additional solution that's been injected into the IV bag. IV solutions are administered over various time frames, from an IV push, which can be delivered in less than a minute, to a continuous infusion, which runs uninterrupted. It can be good to be familiar with an IV set in order to visualize the terms that appear in calculations problems. First, there's the IV bag, which contains the solution that will be delivered. These solutions will come in various volumes and ingredient concentrations. Next, there's the medication port, where additional solutions can be injected into the IV bag. These added solutions will have their own volumes and concentrations to be taken into account. Next is the drip chamber. This helps set the rate at which the IV solution will be administered. The drip rate refers to the number of drops per unit of time, and the drop factor refers to the volume of the drops and is usually reported as the number of drops per milliliter. Finally, there's the rate at which the drug solution will be administered. This can be reported as a flow rate in milliliters of drug solution per unit of time, or as a delivery rate, the amount of drug per unit of time. This slide shows some of the units used for flow rates and drip rates and delivery rates, all in units of time. And one thing to note is the abbreviation for drops. Remember that that's GTT. When I initially went through the book problems for this topic, I found that almost all the problems fit into one of the formulas shown here, where the unknown in the problem could be any of the terms that are listed here, or a part of a term, like the volume part of concentration, or the time part of a flow rate. The formulas on this slide will not be given to you on the assessment. They're just here to provide guidance if you get stuck on a problem and need help putting it into context. Okay, looking at the example problems, the first question asks, what is the flow rate in mils per minute if a patient receives 500 mils of an infusion over 5 hours? So we're going to deliver 500 mils, and the amount of time is 5 hours. So we could report the flow rate in mils per hour as a 100 mils per hour. This asks for the flow rate in mils per minute, so we just need to calculate how many minutes are in 5 hours. So that's 5 times 60, 300 minutes. So 500 divided by 300 is 1.7 mils per minute. Next problem asks 2 questions. So first, what's the dosing rate in milligrams per minute? So milligrams of drug delivered per minute of an IV solution that contains 175 milligrams per milliliter drug administered at 1.3 mils per minute. Well, let's just look at that first of all. So we have a concentration that's 175 milligrams per mil, and we have a flow rate, 1.3 mils per minute. And so I think this is a formula I mentioned on the previous page. If you multiply those together, then you end up with milligrams per minute, which is the drug delivery rate. So 227.5 milligrams per minute. Second question is, how many milligrams of drug will be delivered in 20 minutes? Well, we can use this delivery rate that we just found and set up a proportion. If 227.5 milligrams are delivered in 1 minute, how many milligrams are delivered in 20 minutes? And we will cross multiply, and that's 4,550 milligrams. Okay, next we have a drop counter question. If a drop counter dispenses solution at 15 drops per mil, that's the drop factor. So there's 15 drops in a mil. That tells us what the volume of the drops are. What should the drip rate be? And it's drops per minute to administer 500 mils of an IV solution over 4 hours. So we have the volume and the time over which it needs to be delivered. And so instead of the volume in mils over a unit of time, we want to know the drops, the volume in drops per unit of time. So we have to convert the volume, 500 mils, into drops. So if there's 15 drops per 1 mil, how many drops per 500 mil? And we can cross multiply and get 7,500 drops. And then we have 4 hours, which needs to be in minutes. And so we convert that by multiplying by 60. That's 240 minutes. So 7,500 drops delivered over 240 minutes gives 31.25 drops per minute. Okay, last question. If the drug concentration in an IV bag is 2 mg per mil, what flow rate in mils per minute should be used to deliver a weight-based dose? 0.1 milligrams per kilogram per minute to a 100 kilogram patient. So we can take care of the weight-based dosing first. We have 0.1 milligrams per kilogram per minute. This could be written differently. I've kind of gotten so I like writing it 0.1 milligrams per minute per kilogram. You could put either one on the bottom of milligrams. And so we're asking really how many milligrams per minute for 100 kilograms. So cross multiplying, it's 10 milligrams per minute is going to be the delivery rate. And then we have a concentration of 2 milligrams per mil. And so if we divide by that, then we end up with milliliters per minute. And so we have 5 mils per minute as our flow rate. Okay, take a look at the IV infusion examples for you to try, and we'll work them out in the next video.